Imagine flipping a switch in an ordinary American home. No fuel tank outside, no grid connection humming in the background, no monthly power bill ticking upward. Just silence and electricity flowing anyway. Tonight's story begins not in a secret laboratory or a government facility, but in a real suburban home, where a group of U.S. engineers agreed to test one of the most controversial energy devices of our time, Maxwell Chikumbutso's generator. For years, claims around this technology have divided the internet. Supporters call it a breakthrough. Critics call it impossible. Engineers call it something else entirely, a question that demands measurement, not opinion. So they brought their instruments: power analyzers, thermal cameras, load banks. And they made one decision clear from the start: no assumptions, no hype, no shortcuts. The generator was installed under controlled conditions, isolated from the grid, disconnected from any hidden power source. The home itself was nothing special: standard appliances, standard wiring, standard loads. The kind of place where anomalies are easy to spot and harder to hide. The first test was simple. Lights on. Refrigerator running. Air conditioning engaged. Power flowed. Not dramatically. Not explosively. Steadily. At this point, skepticism didn't disappear, it sharpened. Engineers began asking harder questions. Where is the energy entering the system? Is there stored charge? Is there thermal buildup? Is there RF leakage? Every known explanation was put on the table, not to dismiss the device, but to challenge it. Load was increased. Multiple appliances engaged simultaneously. Measurements were logged minute by minute. The generator didn't surge. It didn't stall. It didn't behave like a traditional generator at all. What caught their attention wasn't just that the house stayed powered, it was how uneventful it was. No fuel consumption. No audible strain. No rising heat profile that would suggest a hidden conventional process. That's when the testing moved from curiosity to investigation. Engineers began isolating variables, turning systems off one by one, introducing control disturbances, monitoring response times, looking not for success, but for failure. And still, the power remained stable. This is usually the moment where bold claims collapse, where reality intrudes, where numbers betray the narrative. But instead, the data raised a more uncomfortable possibility. What if the generator wasn't breaking the laws of physics, but operating in a way most consumer power systems never do? That question changed the tone in the room. The engineers stopped trying to debunk and started trying to understand. Notes became more detailed. Conversations more cautious. Words like impossible quietly disappeared, replaced with phrases like unaccounted input and non-traditional coupling. No conclusions were announced. No victory declared. Only this much was agreed upon. The device was doing something real enough to measure, stable enough to sustain, and unfamiliar enough to warrant deeper testing. And this was only the first home. What happens when such a system is tested across different climates? Different electrical standards? Different loads? What happens when replication begins? Because history shows us something important. Every major energy shift began not with consensus, but with controversy. As the hours passed, the test moved into its most critical phase: time. Short demonstrations can be staged. Batteries can be hidden. Stored energy can masquerade as innovation. So the engineers did what engineers always do. They waited. The generator was left running overnight. No adjustments. No human intervention. Just continuous monitoring. Sensors tracked voltage stability. Thermal cameras watched for gradual heat buildup. RF scanners swept the surrounding spectrum, searching for external coupling or hidden transmission. Data streamed into laptops in real time, quietly recording a story numbers don't lie about. Morning came. The house was still powered. Coffee makers turned on. Showers ran. HVAC systems cycled as temperatures changed. The electrical profile looked normal, almost boring, which, for something supposedly impossible, was the strangest part of all. That's when the engineers began discussing energy pathways rather than sources. Not fuel, not batteries, not the grid. They examined grounding behavior. Ambient electromagnetic noise. Environmental coupling theories that usually live only in academic papers, not suburban basements. The idea that energy could be harvested continuously rather than consumed was no longer being laughed out of the room. It was being quietly modeled. Still, skepticism remained. As it should. One engineer pointed out that extraordinary claims don't require excitement. They require replication. Another emphasized that one house doesn't change the world. Patterns do. A third noted that even if the output was modest, consistency itself could be revolutionary. The conversation shifted again. Not, is this real? But, what scale does this become meaningful? Because powering a home is one thing. Powering a neighborhood is another. Powering infrastructure. That changes geopolitics. At this stage, no press releases were written. No announcements made. The engineers documented everything, sealed their datasets, and agreed on one thing only. This test was inconclusive, but not dismissible. And that distinction matters. Because in science, dismissal ends inquiry. Inconclusiveness invites it. Plans were quietly discussed. Longer duration tests. Independent labs. Different locations. Different electrical codes. The possibility of blind testing, where installers and observers don't know which system is active at which time. The generator, meanwhile, kept doing what it had done since the first switch was flipped. It ran. No drama. No spectacle. Just output. And somewhere between the numbers, the silence, and the uneventful passing of time, a realization began to form, slowly, cautiously, almost reluctantly. If this technology holds up under broader scrutiny, the implications won't arrive as a headline. They'll arrive as a shift. In how power is produced. In who controls it. In what off-grid really means. But that future hasn't arrived yet. And that unresolved step hung in the air as the engineers packed up their equipment. Because the most dangerous moment for any controversial technology isn't the first test, it's the moment after the test, when the data exists but the explanation does not. Back at their offices, the analysis began. Waveforms were rechecked. Logs were cross-referenced. Timestamps were verified against environmental conditions. Engineers who hadn't been present were brought in to review the numbers cold, without context, without story. Just data. And the data refused to misbehave. No sudden drops. No telltale decay curves. No signature of stored energy bleeding out over time. If the generator were secretly relying on batteries, the math would betray it. If it were pulling power from an external source, the instruments would see it. If it were cheating in any conventional way, there would be fingerprints. Instead, what appeared was something more unsettling. A system that behaved as if input and output were decoupled in a way most residential engineers never encounter. That didn't mean the laws of physics were broken. But it did suggest that the system might be operating outside the assumptions baked into everyday electrical engineering. And that's when the questions became sharper. Could the generator be interacting with ambient energy in a way that current residential standards don't measure? Could it be exploiting inefficiencies, noise, or overlooked coupling effects that were never designed to be harvested? Or was there an entirely different mechanism at play, one that doesn't fit neatly into the boxes people argue about online? None of the engineers rushed to answer, because rushing is how mistakes are made. Instead, something quieter happened. Emails were sent. Colleagues were looped in. Not influencers. Not media. Specialists. People known for skepticism, not excitement. People who make careers out of saying no, unless the evidence corners them. And slowly interest spread. Not viral interest. Professional interest. The kind that doesn't show up on headlines but decides what gets funded, tested, and taken seriously. Meanwhile, the home test location remained active. The generator stayed installed. The family living there went about their daily routines. Laundry, cooking, heating, cooling. Life continuing, powered by something no one was ready to name yet. Weeks mattered now, not hours. Because if the system failed after a few days, the story would end quietly. If it degraded after weeks, it would become a footnote. But if it continued, unchanged, uncomplaining, that's when the conversation would have to escalate. And that escalation wouldn't be public at first. It would happen in conference rooms, in peer reviews, in requests for controlled replication. Because the next phase isn't belief. It's pressure. Pressure to reproduce the results. Pressure to explain the mechanism. Pressure to decide whether this is an anomaly or the edge of something much larger. And that pressure is building now. Slowly, silently, relentlessly. Because the generator is still running. That unanswered question, why it keeps running, became the quiet center of everything that followed. Because once a system refuses to fail, the burden shifts. Not onto the device, but onto the people observing it. Additional instrumentation was introduced. More precise. More invasive. The kind of tools normally reserved for certification labs and aerospace testing, not suburban homes. Every new sensor was added with one goal, to force the generator to reveal its limits. Still, nothing dramatic happened. No collapse. No overheating. No hidden dependency suddenly exposed. Instead, a pattern emerged, one that engineers recognize instinctively, even when they can't yet explain it. The system appeared to self-balance, adjusting subtly as loads changed, as temperatures fluctuated, as environmental conditions shifted. Not reactively, like a conventional generator, but anticipatorily, as if the system were coupled to something broader than the home itself. That observation unsettled people. Because if true, it meant the generator wasn't just producing power, it was participating in an environment. Discussions grew more technical. Terms like resonance, ambient coupling, and nonlinear feedback entered the conversation. Not as theories for YouTube debates, but as working hypotheses scribbled onto whiteboards and slowly refined. And still, no public statement. That silence was intentional. Because the fastest way to destroy a potentially real breakthrough is to announce it before it's ready. Engineers know this. Institutions know this. History is littered with ideas that failed not because they were wrong, but because they were exposed too early. So the work continued quietly. Replication plans were drafted. Independent installations proposed. Different homes. Different cities. Different electrical standards. The generator would be removed, reinstalled, retested by teams who had no stake in the outcome. If it failed even once under those conditions, the story would narrow. If it didn't, the story would widen. And somewhere in the middle of all this methodical caution, something subtle but important happened. The language changed. No one said Maxwell's generator anymore. They said the system. Because once a device survives scrutiny, it stops belonging to its inventor alone. It becomes a subject, something to be studied, stress-tested, understood. And that shift matters. Because inventions don't change the world the moment they work. They change the world the moment other people can't make them stop working. That moment hasn't arrived yet, and as that moment edged closer, a new kind of tension settled in, not excitement, but responsibility. Because if the system continued to hold up, the next phase wouldn't belong to engineers alone. It would move into the territory of regulators, utilities, insurers, and institutions that exist to manage risk. And those systems are far less flexible than a lab bench. The engineers knew this. That's why the next tests weren't designed to impress. They were designed to fail the system under controlled stress. Sudden load spikes. Irregular demand cycles. Simulated faults that would normally expose weaknesses in unconventional hardware. The kind of scenarios that don't make headlines but decide whether a technology survives contact with the real world. Once again, the system adapted. Not perfectly, not magically, but within margins that defied expectations for something with no obvious fuel source and no conventional energy storage profile. Deviations were logged. Micro-instabilities were noted. But none of them cascaded. None of them ended the run. At this point, conversations grew quieter. Not because people were convinced, but because they were cautious. Because there's a moment in every serious investigation where speaking too loudly becomes irresponsible. Where speculation can contaminate data. Where belief, positive or negative, becomes noise. So the engineers did the only thing that made sense. They stepped back. They let the system run without attention. No constant observation. No narrative framing. Just long-term operation under normal living conditions, punctuated only by routine data checks. Days turned into weeks. And with each passing day, the simplest explanation became harder to defend, not the extraordinary one, but the dismissive one. The idea that something must be hidden requires increasing complexity to maintain. At some point, complexity itself becomes the red flag. Still, no declarations were made. Because there is one final barrier every energy technology must cross, and it has nothing to do with performance. Reproducibility. Until another team, in another place, with no connection to the original setup, can achieve the same results, this story remains unfinished. Suspended, balanced between possibility and proof. And that's exactly where it stands now. Not as a revolution, not as a hoax, but as a question that refuses to go away. And that is where this story comes to rest for now. Not with a proclamation, not with a verdict, but with evidence still running quietly in the background. The generator remains active. The data continues to accumulate, and the question at the center of it all has only grown sharper. If this system is merely an illusion, time will expose it. If it is something new, time will confirm it. That is how real breakthroughs are separated from noise, not by belief, not by outrage, but by repetition, scrutiny, and patience. For the engineers involved, the conclusion is simple and deliberately restrained. What was tested was real. What it means is not yet settled. And until that meaning is fully understood, the story does not belong to headlines or arguments. It belongs to the process. Because every transformation in energy history, every shift we now take for granted, began the same way, with a system that worked before anyone could explain why.